Hey there. Today we will be having a video which is a little bit different than what we used to have on this channel. I'm not gonna show you how to make the code, the order, thing like this. Instead, we will be reviewing um, this little prototype I've been working on recently. So, in the poll regarding which game you want to see in a series, you asked for Poker Clicker and in majority, so that's what I'm currently working on. Um, yeah, so this episode is not really a start to the series, but instead more of a kind of a showcase of a prototype to show you something quite important in games, and that is state pattern. States are a very, very powerful tool to use in games. If you have followed the starter series, we've used very simple states with enums, but enums have their limitation. So when you want to have more complex states, like the one which is currently looping on screen, I'm right in front of the text. Let's just change this, right, so you can see. Um, yeah, when you want to make something a little bit more complex like this, enums won't just cut it. So in this video, I will just show you the actual structure of code behind this little application here, so that you can, if you wish, try to create your own states. And yeah, if it is a little bit too complicated, don't worry, that will be developed in the Bokeh Clicker series. So yeah, it's gonna be alright. So yeah, just looking back at the prototype here, this one has three states. You have the idle state, you have the combat state, and then you have the capture state, which is right now. So when you define state like this, you actually need to define each and every state somewhere in the script. So there are many ways to do that, and there is no right way, no wrong way, there's just different ways, and which one suits you better, right? So just so you know, I used to make a lot of states on Unity, so I know how to make states on Unity, but on Godot, I've never used those, right? So here it's quite a first try. So don't take this as the absolute perfect best state pattern there is, but it works. That's all we're asking for, right? So let's dive a little bit more in what we have here. So we have a state manager node, right, which is in my scripts node. And under this state manager node, I have my three states: idle, combat, and capture. So the idea is that the state manager here will switch which node it is using based on the state of the prototype. Okay, so we can go look into this state manager script. So here we do see that in the variables we have the references to the three nodes here, which are idle, combat, and capture state. And then we have another variable, which is a local variable, which is the actual current state, current active state. Okay. All the states have the same type, which is prototype state abstract. So basically, it's the abstract state class that is going to be applied to each and every state. And it's very important that each state inherits from the same abstract class, so that you can, you know, call on the common methods between the states, right? Because all three states, they have common methods, which we will get into very quickly. So the state manager has only two methods really, plus the ready method. So we have the change state method, which is just a little bit of logic to allow the code to change from one state to another. Very simple. So we just check that it is not the actual state because we don't want to change the state to itself. Then we check that there is actually a state, and if there is a state, we will leave it, calling on the leave function. We change the state to the new one, and we call on the enter state function of the new state. Right, so this isn't necessary for the state pattern. You don't need the leave state and enter state method. It just makes it easier to implement certain features, which will be very clear when we get into the specific states. Here I have a master script, which is pretty simple as well. I just grab the state manager and most of the interactions there is in the application. So here we have the two buttons, which are at the bottom right here. And we grab signals which are emitted by specific states themselves, right? So let's look at the idle state, for example. It's the simplest one. So here we are inheriting the prototype step abstract, right? So that's here it is. Here that's a script that I created on the side, and it is attached to nothing, right? It's just an abstract class which is meant to be creating those common methods between each state so that the state manager here knows that we do have a leave state, we do have an enter state, and we do have a process state. I will get back to this process state a little bit later, all right? This process method, sorry. So yeah, let's go back to the idle state. Here, we just have an enter state method and a leave state method. We don't need to use process, so since we don't use it, I didn't redefine it afterward. Here, when we enter the state, I want to change the label to display that we are currently idle. I just want to make sure that the progress bar is resetted to 0 because I don't want it to be in the middle or stuck anywhere. And I simply have a little print entering idle state, which will show in the console, just to be sure that, yeah, that's what happened, right? And when we leave the idle state, there's actually nothing we want to do, right? Instead of more than just saying we are leaving idle state, right? So that is a very, very, very simple state, because when you're in idle, you do nothing, which is where you don't have process, and you just reset a few things. Now we have the combat state, which is where things start to get a little bit more complex. So again, we have the extension from prototype state abstract. It's a given. Here we have a few references to the timer, which is the combat timer, and the progress bar, which is the progress bar in there. I've created a progress variable, which is just a way for us to simulate the idea of having a Pokemon getting HP, and when the HP are down, we capture it, right? So that's just to simulate this. We have the enter state, just like we had that with idle. Here, again, we initialize the label, we initialize the progress, and we start the timer, okay? And when we leave the state, we actually do want to do something, which is stopping the timer this time, right? So that timer resets if we get in and out. So you can see that result by getting in combat, leaving it, and when you enter back, it resets whatever progression you had on the attack. All right. We have a little check progress method, which is just, again, used to simulate the Pokemon having HP. And here we emit a signal, which is Pokemon defeated, signal declared here, of course. So that the master script, master node here, will catch this, right? Where is it? It's here. It will catch the signal and force a change state. Okay. Let's go back to combat. Yeah. So now we have the process method in there. So the thing is, the process method usually uses an underscore process like this. Okay. But there is a catch with the state pattern. And the catch is that we don't want each state to run their own process all the time. We only want the active state to be running its process alone. Okay, so here, if I go in the capture state script, I do have another process method here. And I actually don't want both to activate at the same time. It's going to be doing really messy things. So instead, I'm using a process method without the underscore, and I'm having the state manager say during his own process, which is the underscore one, I will call on the process of the state and only the current state and not the other ones. Okay. Then back to the combat states, we have a last method, which is just whenever the timer which we started by entering the state completes a loop, we get one progression and we check whether we have defeated the Pokemon or not. Right? So since there is no capture button on there, in order to switch from the combat state to the capture state, it is actually necessary to reach that method here and get a progress of 3 or more. Because then we will emit the signal, which will force a state switch right there, which will start the capture state. Okay, so the capture state is quite similar. We have a timer, we have something happening on timeout, but the main difference is that the time is 3 seconds instead of 1, right? So yeah, just like the other one, when we get in, we change the label, we start the timer, so this time it's the capture timer, it's a different one. When we leave, we stop the timer, so there's no print, but we could print leaving capture state. In the process, we just update the progress bar based on the elapsed time. And here, when the timer is done, we just make a little head or tail check and get a success or failure. Called failure. So anyway, we update the notification on bottom left, and then we emit a signal which says capture completed. And again, once the capture is completed, the state changes back to the combat state, because right there, we grab the uncapture completed state, and we change the state to get the combat state, right? So this is how we can implement a simple state pattern in Godot. So state pattern, even though it is simple, even though it's a simple one, is still more complex than using enums, but it allows far more things to be done. It's easier to work on later on because everything is separated very clearly, right? So if you want to change something which is combat related, you go in the combat state, etc., etc. Here, the combat state and the capture state, they both have a process method. The fact that they are separated in different files, different scripts, and different nodes actually help us not having, the capture script being mushed together with the combat script, right? So they are all separated and in their own boxes. And that is great. That is very great. It really increases the readability, the scalability, the etc. etc. So yeah, that's it for this little showcase episode on how I have implemented this very simple poke clicker combat loop using the state pattern in Godot. So if you want to recreate the state patterns, go ahead. It's very cool, very useful. And yeah, I hope you like this episode, and I will see you in the next one, which will where we'll be talking about what will come for this project of the series of Pokéclicker, and how you will be able to participate in the processes of making this series. So anyway, see you later.